Hello everyone. In this video I am going to demonstrate a switching power supply. As you can see, this is my switching power supply. This transformer you have seen I have winded in the previous video. So as you can see, I will again show you the transformer. So this is a toroidal transformer wound on a toroidal ring core. As you can see this. So the primary of this transformer I am going to feed 48 kilohertz. So I will be using an oscillator to oscillate the power supply, and I will be feeding 220 volts DC mains to this transformer. As you can see here, these are the primary of these two wires are the wires connected to the primary of this transformer, this toroidal transformer. The primary of this transformer is having 235 turns of copper wire. The primary is 235 turns of copper wire. The secondary is, there are two secondaries, 14 turns of bifilar winding, thin wire, and thick wire, 25 turns of thick wire bifilar winding. So as you can see here, the thick wires I am not using yet. They are just as a spare. I will be using them in a next video. In the next video, when I am going to extract high power from this device. So till now you can see these wires are still not in use. But the thin secondary wires are already in use. You can see I have connected the winding as a bifilar winding. You can see this is the center tap. You can see the black wire is the center tap, and these are the two halves. You can see this is plus something, plus 19 volts, and this is minus 19 volts, like plus minus 19 volts. This is the center tap. If you add them, it will be the addition of the two windings. This is just an example of bifilar winding. So now you can see here, this is the toroidal transformer. I have fixed it on this plastic plate. Now as you can see here, this is a switched power supply, as I have discussed before. So I am going to use a bridge rectifier first. So I will be converting the mains 220 volts AC mains into DC. So I will be getting somewhere like 310 volts DC. So there is a filter capacitor here. After the filter capacitor, the DC line I am feeding to this MOSFET via this primary transformer. Okay, and the gate of this IGBT, I am using an IGBT here. This is the switching device. You can see here, this is the switching device. The switching device is 25N120. So this is the switching device IGBT. So I am using this IGBT for the power switching, power stage. So as you can see here, on the gate of the IGBT, I have connected this toroidal transformer, small transformer, to give the frequency, switching frequency to the IGBT. I am not connecting the IGBT directly to the oscillator, because there is a voltage there is high voltage. This is a high voltage device, so I don't want to damage my oscillator. I am keeping the oscillator isolated from the IGBT. So if there is any problem in the IGBT, any issue in the IGBT, any damage in the IGBT, it will not affect my oscillator. So this is the oscillator. The oscillator is based on 555 timer IC. You can see here, this is the oscillator based on 555 timer IC. I am having a MOSFET, the IRF 840 MOSFET. This winding is used. The primary of this transformer is connected between the power supply rail and the drain of this MOSFET, as you can see. And the secondary of this transformer is directly connected to the IGBT. You can see here, IGBT gate and IGBT, just a minute, IGBT base and IGBT emitter. You can see this is the IGBT emitter, and the first one is the IGBT base. This is the IGBT base, and this is the emitter. Okay, and the collector of the IGBT is connected to this is, just a minute, Yeah, this is the collector of the IGBT. IGBT is connected to the transformer, and the other winding of the transformer is connected to 220 volts main line. You can see here. So like this, I have wired the circuit. So this is how the circuit looks like. So now I am going to power up the circuit. You can see it is having 220 volts already. So as you can see here, the voltage on the, you can see the voltage is 19 volts AC. You can see the frequency is 50 kilohertz, 42% duty cycle, and the voltage is 19 volts AC. The voltage is 19 volts AC on one side of the winding, center tapped. So if I am using both the windings, like winding to winding, the voltage will be 19 into 2. Okay, so around 20 volts I will be getting. Between, if I connect multimeter between here and here, it will be 20 volts. So this is how the circuit looks like. Thanks a lot. Thanks for watching.